You left the party early, traveling 3 miles per hour. 2 hours later, Nicole decided to head out and catch up with you. But she's running at 4 miles per hour. How long would she have to run to catch up with you? Now, again, how long generally indicates that we're looking at some form of distance. In this case, since we're going at miles per hour, we're looking at some number of miles. Okay, so right here, we'll say that the distance that she's going to have to travel is D. That's how many miles just Nicole has to run, right? Because she's going faster than you, she's going to catch up. Now, of course, there's a backdoor way to do this one. I'm going to talk about it after I do all this equation stuff, okay? So here's the thing is the distances are going to be the same, right? Because Nicole's catching up to you, and that's a crucial part because in order for Nicole to catch up to you, she has to be at the same distance, okay? So I would be looking at these probably for some kind of distance formula, all right? And we know that distance equals the rate times the time. Now, the two good things that we do know about is the rate and well, we don't know exactly the times, but we can use t as a variable here. So it looks like we may need both variables, or just maybe again, it's kind of like we're gonna have to find out how much time it takes her, and then that will help us to figure out how many miles she's going to have to run. So in order for Nicole to catch up to you, she's gonna have to run the same distance. So again, I'm gonna start with distance formulas on these, okay? So there's two distances. We have your distance, it's you, and then we have Nicole's distance, right? Well, your distance and Nicole's distance, we want to find out where they're equal. We just don't know how much time that's going to take. So again, I'm going to actually have to define another variable. I got t, which is time. Again, in hours. It's how much time it takes for Nicole to catch up to you. Now, for your distance, let's see. We have your rate. It showed your rate as 3 miles per hour. So your distance would be 3 times the amount of time. Now, your time is not how much time Nicole traveled, right? So you will travel the same amount of time Nicole traveled. So I got the t there. Again, that's the time that Nicole travels. So I'm going to specify that here. But you also left 2 hours earlier than Nicole. So you got Nicole's time, but then you're going to add 2 more to that. Okay, and this should be equal to whatever Nicole's time is. We do know that she ran at 4 miles per hour, so I'm going to take 4 and multiply it by the amount of time that she ran. Now, if by chance here you said, well, the t is the time that you ran, well then Nicole's would have been t minus 2, and yours would have been a t right here. But you're going to get exactly the same amount of time. It's just that, remember, the answer wants how many miles, how many miles Nicole ran. So you need to figure out still how many hours that Nicole ran to catch up to you. But this becomes an equation that we just need to solve at this point. So I'm going to distribute the 3. 3 times t is 3t. 3 times 2 is 6. And this still equals 4t. Not 40, but 4t. And last up here, to solve this one, we're gonna get rid of that 3t. So I'm gonna put my t's on the right. Doesn't really matter that it's there. I almost use x, but let's use t instead. So 3t's minus 3t's is 0. I can drop my 6, which now equals 4 minus 3t's would just be, you can show it as 1t, but I'm gonna make it a phantom 1. Now the reason why that is because that should solve the problem. Or it should solve the problem to this point, right? So 6, that's how many hours Nicole ran. But it didn't want how many hours Nicole ran, right? What we want is the distance. D is the distance. So the distance, right? We have the formula. We now know how many miles or how many hours rather, that Nicole ran. She ran for 6 hours. We know from the problem that she ran at 4 miles per hour. That's a rate. 4 times 6. That's the distance that she ran. She ran for 24 miles, which, if I'm not mistaken, is close to or more than a marathon. But Nicole is going to run for 24 miles, and that would be our final answer right there. But again, we did have to. This one was very different, I would say, because we did set up the distance, but we also had to have a variable in there. We didn't know how much time it took her, but the time was what helped us to actually solve the problem, how many miles that she had to run. How would you know that? Well, again, you may have to do some trial and error on this one. Maybe you set up a time formula in here or a rate formula. But again, the rate was given directly. The time wasn't, right? But again, one of the key factors in this that we need is that she's going to catch up with you. And that is how we made this part of the formula. It was a distance. That's what it means to catch up. It was an equal distance on that one. In the past few problems we saw, it's like, all right, you run a certain distance and Nicole runs away from you. We want to know when you're this far apart, or you're running together and you start this far apart, this kind of thing. But now it was like, well, we need the distances to be the same. Again, all this comes from reading the problem. You notice that I went through the problem, I would say 2 or 3 times throughout this. You may just have to read and reread and reread and reread and reread the problem until you understand what it really wants and then how to set things up. But again, even that, you may have to do some trial and error before you can get to this point where it's like, all right, I see this, I can solve it. I'm not saying it's fun, but it is something you'll probably have to do until you get used to it.